Assalamualaikum and hi, my name is Muhammad Irshad. We are from Group 4 CST338 project, and today we will be presenting about anti-malware gateway and endpoint integrations. The tools that we are using is Clamav and also Cuckoo Sandbox. Our group member consists of four. The first one is our leader, which is Anwar Ridwan. The second one is me. The third one is Muhammad Zulhilmi, and the fourth one is Hurin Damia. Next, problem statement. So this is the main problem we are addressing in our project. Firstly, next project justifications. So this slide explains why our project approach is appropriate and relevant. By integrating Clamav with Cuckoo Sandbox, we implement a defense in-depth strategy where multiple layers of security are used instead of relying on a single detection method. Clamav performs static signature-based analysis at the gateway level, while Cuckoo Sandbox performs dynamic behavioral analysis by executing suspicious files in an isolated environment. This combination improves detection accuracy by allowing us to detect both non-malware and unknown or evasive threats. Both Clamav and Cuckoo Sandbox are open source tools, which makes them suitable for academic use and allow transparency, flexibility, and also reproducibility. Finally, this project reflects real-world malware detection practice used in enterprise and security operations environments. The project objective. The first objective is to configure Clamav as an anti-malware gateway to perform initial scanning and also block non-malicious files. The second objective is to integrate Cuckoo Sandbox for a dynamic malware analysis, allowing us to analyze suspicious or unknown files through behavioral execution. The third objective is to demonstrate the full detection process, including malware identifications, analysis, logging, and also reporting. Finally, the project aims to show a layered malware defense approach where multiple security mechanisms work together to improve overall detection's effectiveness. Next is system architecture. So this illustrates the overall system architecture of our integrated malware detection system. The files originating from the internet, such as downloads, email attachments, or transfer files, first enter the system through the Clamav gateway. And at this stage, Clamav performs static signature-based analysis to detect the non-malware. If a file is identified as a malicious, it is immediately blocked and quarantined. If a file is suspicious or cannot be confidently classified, it is forwarded to the next layer. The suspicious file is then sent to the Cuckoo box, where dynamic analysis is performed by executing the file in an isolated virtual environment. Cuckoo Sandbox observes runtime behavior such as process executions, file system changes, and network activity. Finally, a detailed behavior report is generated, providing insight into the file's malicious actions. So this layer design follow a defense in-depth approach, improving detection accuracy and also system security. So let's move to the main part, which is the Clamav. So Clamav is configured as an open source anti-malware gateway and as the first line of defense in our malware detections architecture. All the incoming files are scanned using signature-based detections before they are allowed to proceed further into the system. When a non-malware signature is detected, Clamav automatically blocks the file, quarantines it, and records the event in the system's log. This early detection stage prevents known threats from reaching internal systems and reduces the overall attack surface. Why Clamav? So Clamav is an open source and widely used anti-malware engine, making it suitable for both academic and real-world security environments. And it is effective for fast signature-based malware detections, which allows known threats to be identified quickly at the entry point. Clamav also suitable for gateway level scanning, meaning it can scan incoming files such as downloads, email attachments, or transfer files before they reach internal system. In addition, Clamav is a lightweight and easy to integrate with other security tools, which makes it ideal for use with Cuckoo Sandbox in a layered security architecture. Clamav role. So when an incoming files enter the systems, it is first scanned by Clamav. ClamAV then performs signature-based analysis to check whether the file matches any known malware signatures. If the malware is detected, the file is immediately quarantined and the detections event is logged for auditing and monitoring purpose. If no known malware is detected, the file is not blocked and is instead forwarded for further analysis. This ensures that known threats are stopped early, while suspicious or unknown files can be analyzed more deeply by the net security layer. ClaimAV Gateway environment. This is the environment where ClaimAV is deployed in our project. We configure an Ubuntu virtual machine to act as an anti-malware gateway. This virtual machine is responsible for handling incoming files and performing malware scanning and logging using ClaimAV. The operation system details are shown using the lsb release -a command, which confirms the Ubuntu version used in our environment. The IPA command is used to display the network interfaces, verifying that the virtual machine is correctly connected to the network. IP forwarding and firewall rules can be checked to demonstrate that the system is capable of routing traffic if deployed as a gateway. This setup simulates a real-world gateway environment where files are inspected before being allowed to proceed further into the system. The next video demonstrates the validations of these gateway environments where these commands are executed to verify the system configurations and ClaimAV operation. Next, this confirms that ClaimAV has been successfully installed and is fully operational in our gateway environment. The ClaimAV daemon is active, which enables a real-time and on-demand malware scanning. The virus signature database is up to date through the FreshClaim service, ensuring that the system can detect the latest known malware threats. The commands shown on these slides are used to verify the ClaimAV versions, check the status of the scanning daemon, and update service. And it also confirmed that the signature updates are functioning correctly. The following video show these commands being executed to validate that ClaimAV is installed, running, and up to date. Malware detections, ACAR. This slide demonstrates malware detection using the ACAR test files. ACAR is a standardized and safe test string that is commonly used to validate antivirus detection without using a real malware. In this test, we download the ACAR file into a test directory within the ClamAV gateway environment. We then scan the file using both ClamScan and ClamD-scan to demonstrate detection through the ClamAV engine and the ClamAV daemon. Successful detection of the ACAR test signature confirms that ClamAV is functioning correctly and is able to identify non-malware. So the next video shows the executions of this command and the successful detections of the ACAR test signature. Now this is where how malware detection events are logged in our Clamav Gateway environment. On Ubuntu system, Clamav daemon logs are recorded through the systemd journal rather than only traditional log files. We use the journalctl command to retrieve recent log entries generated by the Clamav daemon. So these logs include important information such as malware detection events, file path, timestamp, and scan results. The presence of echo detections entries in the journal confirms that ClaimAV is not only detecting malware but also properly recording security events for auditing and monitoring purpose. So next the video shows the executions of this command and the corresponding log entries produced by the ClaimAV.
Okay, I will be presenting HTTP scanning demonstration. For the HTTP demonstration, the HTTP downloads go to a controller directory and are scanned automatically. So in this case, we use two terminal. First terminal is for the washer running and second to trigger the download. So for the first terminal, we use code sudo USR local bin http underscore scan dot sh to the washer running. It will be wash the run of the code. And second terminal, we code the sudo wget and the acar underscore http website itself. So it will be secure.acar.org and the acar.com.txt. And then we will present the output with the code sudo tail dash n 50 for the 50 line only var log screen av http underscore scan dot log. So the next slides will be the demonstration, will the full demonstration. Okay, next for the FTP scanning demonstration, FTP will be uploaded and are monitored and scanned automatically. So in this, we use also two terminals, same with HTTP. The first terminal is for the washer running. Different with the HTTP, it will be the code sudo usr local bin ftp underscore scan dot sh. And then for the second terminal, we use to the upload via FTP. So first we log in to the FTP localhost. So FTP localhost, and then inside the FTP, we cd the upload, and then we put the pass for the aka.com.txt for the aka underscore ftp.txt for the file. So we put the pass to the aka.com.txt and we close the FTP and back to the terminal itself, terminal 2. So we present the output by the code sudo tail under dash n 50 line and var log clam every ftp dot scan underscore scan dot log. So the next slide will be the FTP scanning demonstration, full FTP scanning demonstration. So for the last one is postfit plus claim every meter demonstration. It is this will be to demonstrate that email attachment are scanned and the gateway using postfit integrate with the claim every meter and that malware detection capability is active. So this for this section we have 5 steps. First, we verify the required service are running. So we run the following commands: sudo systemctl status postfix dash dash no dash 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 no pager, and also for the claim every daemon and claim every filter. So expected result will be active running. So for the second step, we will be verify filter socket availability. So we check that the claim every filter socket is exist. So we use the code ls-l run claim every filter.ctl. So the expected result will be s read read write claim every claim, and the last one claim every filter.ctl. It will be the confirmed postfix can communicate with the claim every filter. For the second step, for the third step is the verified postfix filter configuration. The it will this one to confirm postfix is configured to use claim every filter. So we use code sudo postconf dash n grep dash I filter. So for the expected configuration, it will be list all the filters list, and then it will to confirms both SMTP and local email submission are route through the filter. Next, we go to step number 4. Step number 4 is to prepare malware test attachment. It is a card. It is to navigate to the test directory. We use the code cd claim every dash test to we go to claim every dash test first, and we ls to ensure the file exists. We search for the aka.com.txt. If not present, we will use the other codes to input the aka.com.txt. And then for the step number 5, it will be to send test email with malware attachment. This step is to send an email from gateway to gateway with the ACAR file attached. So we will use code echo. This is malware test email, and the mail dot dash s claim every test email, and then dash a aka.com.txt gateway at localhost. The explanation is mail for the sends local email, dash a for the attach the aka file, gateway at localhost for the local recipient via postfix. And then the last step is the step number 6. So we verify the email processing and logs. So we check email system log with code sudo tail dash n 50 var log mail dot log. It typical observe behavior in lab environment. Email is accepted and delivered. Postfix attempts filter processing. Filter service remain active and connected to ClaimAV. So we check the filter activity log with the code sudo tail dash n, and then last one ClaimAV dash filter.log. So the expected entries include the started local socket units var run ClaimAV claimd .ctl added probe for slot return is success. So the next slide is will be the full demonstration for the postfix and ClaimAV postfix and ClaimAV filter. So it will be for the email attachment scanning. That's all.
Hello everyone, my name is Surindamya, and for my part, I will explain the setup and also the configuration of a Cuckoo Sandbox. So, Cuckoo Sandbox is an automated malware analysis tool that runs suspicious files in an isolated environment. This allows us to safely observe a malware behavior without affecting real systems. The dashboard shown here indicates that Cuckoo has been successfully set up and is ready to use. So why Cuckoo Sandbox? So Cuckoo Sandbox is used because traditional antivirus systems mainly rely on signatures, which are not effective against new or modified malware. Cuckoo focus on dynamic analysis, meaning it observes what a file does while running. This includes file changes, process creation, and also network activity. Because of this, Cuckoo is useful for detecting suspicious behavior that static tools may miss. So for the environment setup, the analysis environment is set up using Ubuntu 18.04 as the main server. Cuckoo Sandbox version 2.0.7 is installed, which requires Python 2.7.17. These versions are used to ensure compatibility and stability. This system acts as the control center for managing malware analysis tasks. Other than that, MongoDB is required for Cuckoo's web interface to function properly. It stores analysis result, logs, and also task information. The network is configured using a host-only adapter to isolate malware traffic, and the IP address in the 192.168.56 range confirms that the network is correctly set up. So for Cuckoo configuration and integration, Cuckoo uses several configuration files to control how analysis is performed. The Cuckoo configuration file is used to configure the result server, which receives data from running samples. The VirtualBox configuration file allows Cuckoo to manage virtual machines automatically. Snapshots are used to ensure every analysis starts from a clean system state. The slides confirm that the setup and configuration process is complete. The terminal output shows that Cuckoo has successfully loaded all required modules. The screenshot also shows the virtual machine snapshot clean is detected. The message waiting for analysis task indicates that the sandbox is ready to receive samples. At this stage, the system is fully operational.
I am going to present for the Cuckoo Sandbox tool, which is the testing and analysis part. For the testing part, the aim is to test whether the uploaded file is a type of malware or not. And for the analysis part, the aim is to analyze potentially malicious files behavior during its runtime on a virtual machine. We call it Sandbox. So for the testing part, uh, the process is carried out in an isolated environment. For the host operating system, we use Ubuntu virtual machine, and for the guest operating system, we use Windows virtual machine. This guest OS will be used to carry out the the activity of malware. So for the Ubuntu virtual machine, we use NAT as the type of the network. So this virtual machine have access to the internet. Whereas for the Windows virtual machine, the type of the network is uh, host-only adapter, where it does not have access to the internet, since we are trying to analyze a malware. So it is better to not provide the internet access for to the Windows virtual machine. So both of these virtual machine are using VirtualBox software. The first step of the testing part is we need to copy the URL obtained from the Cuckoo terminal. After we copy it, uh, we can paste it into a web browser. For example, a web browser that is available in Ubuntu operating system is Mozilla Firefox. So you can use Mozilla Firefox to paste the URL. So after we press enter, the Cuckoo Sandbox web user interface will appear and will be available to use. So after that, we can then choose files to upload for testing and analysis on the Cuckoo Sandbox. So for this project, we decide to use the eCar test file, since it is considered safe to be used for the testing. After that, after we have choose the file that we want to test, then we will go to this page, where this page, it will show more detail about the file. So we can choose which file that we want to test and analyze. You can either choose all of the files, or you can choose several of it. Once submitted, uh, the file the file have uh, that we have selected will be sent to the sandbox, which is the sandbox will use the Windows virtual machine to carry out the analysis process. Like I said just now, uh, the Cuckoo Sandbox will use the Windows virtual machine to carry out the testing and analysis process, since we have configured the Cuckoo Sandbox to perform the the analysis process on the Windows virtual machine. So the potentially malicious file behavior can be observed through the Windows virtual machine. Uh, After waiting for several minutes, the, the analysis is done. So when it is done, we can validate it through the message that is shown at the Cuckoo Sandbox terminal. After the testing process is done, we can see a report about the malware. So in this report, we can use it to analyze the behavior of the malware during the runtime of it on the Windows virtual machine. In this analysis part, we can observe the behavior of the malware through several types of analysis. Uh, the examples of the analysis are behavioral analysis, network analysis, dropped files, process memory, and so on. For behavioral analysis, you can observe the behavior of the malware during its runtime on the Windows virtual machine. For the network analysis, you can see what the malware does on the computer network. You can also see what files were dropped by the malware, and also you can see the process memory during the malware's runtime on the virtual machine. For the testing part, first we copy the URL that generated by the terminal, specifically the Cuckoo Sandbox terminal. Then we paste it on the Mozilla Firefox web browser. After that, we can see the UI of the Cuckoo Sandbox appear. So we can see where the details of everything inside the Cuckoo Sandbox. So this is a part where we can submit a file for analysis. So in this project, we will use this file, which is a car file, to perform the testing part. So we will choose internet. You can see we can choose the priority of the process. You can decide whether the timeout that you need and the options of the process that you can choose. So we will choose this ACAR file, and before we analyze, uh, we are using a Windows 7 with 64 architecture for the Sandbox virtual machine, and we already create a snapshot of it. So once we press analyze, the virtual machine of the Windows will appear. So in this virtual machine, the malware will be executed. So when the malware is executed, uh, we have to wait for a while for the Windows to become stable. Okay, so you can see uh, the Internet Explorer is suddenly appeared even without I open it. And one thing you can also observe is the cursor is click and move by itself. So it means the malware is executing on this virtual machine. As you can see, the cursor is moved without I moving it. So you can see the runtime of the malware in this sandbox. You don't have to worry since the malware is executed in an isolated environment. So the malware uh, won't disturb the process. So you can see the task is completed and has been reported. So the report is now available to see. So we can validate the process whether it is complete or not by checking the Cuckoo Sandbox terminal. So in this terminal, you can see the message where it shows that the task for this malware testing is done. So this is the summary page where you can perform the analysis part. So you can see the details of the malware file that we used just now. You can see the score of the malware. You can see the signatures that carried out by the malware. You can see it performs some HTTP requests, allocates read write execute memory, changes read write memory protection to read execute, so on. So these are the signatures that you can analyze, that you can use to analyze. So this is the dangerous part where it resumes a suspended thread in a remote process, potentially indicative of process injection. So the red part is the most serious part. So you can also see the other details of the summary. So this is behavioral analysis where we can uh, refer to analyze the behavior of the malware. So as you can see, it used Internet Explorer application during its runtime, and this is the drop files part where you can see the details of each file each file that is dropped by the malware during its runtime. And also you can check the process memory that has been executed, that are executed during the malware runtime. And this is the network analysis page where you can analyze the network part, what the malware has done on the computer's network. So this there are others analysis that you can check. So yeah, so these are the main. The conclusion for our project is both of the tools, which are Clamav, a malware detector, and Cuckoo Sandbox, a malware analysis system, can both be integrated to form an anti-malware gateway and endpoint that can protect and secure uh, any networks or communications from attack agents like malware. So it protects by detecting the malware by using the ClaimAV tool and analyzing the malware behaviors through the Cuckoo Sandbox tool. Both of this integration will make a network will make any networks or communications secure, since both of these tools uh, are combined to form a good security mechanism. That is all from our group. Thank you.